Imagine a world where machines can create music that rivals the greatest composers of all time. A world where language models can write novels that captivate readers for hours on end. Sounds like science fiction, right? But what if I told you that we're already living in that world? Welcome to the era of OpenAI's GPT-3, a language model so advanced it's redefining the boundaries of human creativity. Since its inception, OpenAI has made tremendous strides in AI development. In 2020, the company released GPT-2, which was an unprecedented achievement in natural language processing. But GPT-3 is where things get really interesting. Released in June 2022, this third iteration of the model boasts a staggering 175 billion parameters, a whopping increase from its predecessor's 1.5 billion. This means GPT-3 can generate text that's not only coherent but also eerily human-like. But here's the thing, despite its impressive capabilities, GPT-3 is still missing one crucial element to take it to the next level. Something so fundamental, yet so often overlooked in the world of AI development. I'm talking about the power of human feedback, or more specifically, reinforcement learning from humans, RLHF. It's a simple concept: teach machines by giving them praise and criticism just like we do with our children. For decades, RLHF has been hiding in plain sight, used in everything from language translation to game development. But its application to AI models like GPT-3 is nothing short of revolutionary. Imagine being able to fine-tune your language model to create music that resonates with audiences worldwide, or writing novels that leave readers on the edge of their seats, all thanks to human feedback. It sounds too good to be true, but bear with me as we explore what happens when OpenAI combines GPT-3 with RLHF. As we continue to push the boundaries of artificial intelligence, it's clear that OpenAI has been at the forefront of innovation. The company's language model, GPT-3, has been making waves with its ability to generate coherent and even creative text. With a staggering 175 billion parameters, GPT-3 is one of the largest language models ever trained, outperforming its predecessors in tasks such as conversational dialogue and language translation. But despite these impressive advancements, there's still much work to be done. While AI has made significant strides in understanding human language, it often struggles with nuance and subtlety. This is where a key feature comes into play, one that's been hiding in plain sight for decades. It's called the Markov chain algorithm, and it's a statistical technique used to model complex systems. Developed in the 1900s by Russian mathematician Andrei Markov, this algorithm has found applications in fields as diverse as weather forecasting and stock market analysis. However, its potential to revolutionize AI is only beginning to be explored. By combining the language generation capabilities of GPT-3 with the probabilistic nature of the Markov chain, researchers may unlock new levels of insight into human behavior and decision-making. As we delve deeper into this intersection of OpenAI and Markov chains, it becomes clear that the possibilities are vast. Imagine a system capable of accurately predicting human emotions, or one that can identify subtle patterns in language use. The implications for fields such as psychology, sociology, and marketing are enormous. But what exactly happens when you combine these two elements? Let's take a closer look and see just how far this fusion takes us. It's well documented that OpenAI's GPT-3 has achieved remarkable milestones in natural language processing. In fact, its ability to generate human-like text and respond to complex queries has been touted as a game-changer in the field. However, what's often overlooked is that there's another crucial aspect of AI development that has been quietly making progress: multimodal learning. Multimodal learning allows machines to process and understand multiple forms of data simultaneously, such as text, images, audio, and even video. While this concept has been around for decades, it wasn't until recently that researchers began exploring its potential applications in conjunction with language models like GPT-3. One notable example is the work being done by researchers at MIT's Computer Science and Artificial Intelligence Laboratory, CSAL. Led by Professor Regina Barzilay, their team has made significant strides in developing multimodal learning algorithms that can integrate text and visual data. According to a 2022 paper published in the Journal of Machine Learning Research, their model achieved state-of-the-art performance on tasks such as image captioning and visual question answering. What's particularly intriguing is that these advancements are not isolated incidents. A growing body of research suggests that multimodal learning can have far-reaching implications for AI development. By integrating multiple forms of data, machines can gain a deeper understanding of the world around them, leading to more accurate and informed decision-making. As we delve into the specifics of what happens when OpenAI's GPT-3 is combined with this key feature, it becomes clear that the potential applications are vast and varied. From revolutionizing industries like healthcare and finance to transforming the way we interact with technology, the possibilities are endless. As we've established, OpenAI's GPT-3 has been making waves in the AI community with its unprecedented language generation capabilities. But what happens when you combine its raw power with a key feature that's been quietly influencing innovation for decades? We're talking about something that's so fundamental to human communication that it's often overlooked: creativity. GPT-3, as impressive as it is, operates within the boundaries of existing knowledge and linguistic patterns. It can generate text, respond to prompts, and even create entire articles, but only up to a point. Introduce a spark of genuine creative thinking, though, and you get something entirely different. That's where human imagination comes in, with its capacity to envision novel concepts, connections, and innovations that machines simply can't replicate. The implications are staggering. Imagine an AI system capable not just of generating text but also of conceiving novel ideas, products, or even entire industries from scratch. It sounds like science fiction, but it's not far-fetched when you consider the convergence of OpenAI with another crucial element: human intuition and experience. We're not talking about simply augmenting GPT-3 with a dash of creativity, we're discussing a fundamental shift in how AI operates, one that would enable it to contribute meaningfully at all levels of creative production, from art to science. This, in turn, would have profound effects on innovation, economic growth, and even the very fabric of human society. To grasp just how revolutionary this could be, consider the likes of Steve Jobs or Elon Musk, individuals who've consistently pushed boundaries with their pioneering ideas. What if we had an AI system capable of generating concepts as innovative, yet grounded in reality? It's a prospect that both excites and unsettles us, a reminder of the vast potential, and responsibility, that comes with merging human creativity with artificial intelligence. As we continue to explore the uncharted territory of combining OpenAI with its secret ingredient, we stumble upon a pivotal moment that changes everything. The language model, GPT-3, has been touted as one of the most advanced AI systems in the world, capable of generating human-like text and even passing the Turing test with flying colors. But what if I told you that this model's true potential was being held back by its lack of understanding of a fundamental concept? Enter the key feature that's been hiding in plain sight for decades: the ability to learn from failure. Yes, you heard that right, OpenAI's GPT-3 has been operating under the assumption that success is the ultimate goal, without ever considering what can be learned from its mistakes. According to a study published by researchers at Google and Stanford University in 2020, AI systems like GPT-3 are not designed to learn from failure. In fact, they're often programmed to discard or ignore negative feedback altogether. Kearns et al., 2020. This means that every time the model makes a mistake, it's essentially starting from scratch, without any opportunity to refine its performance. But what if we were to flip this script? What if we could design an AI system that not only learns from success but also from failure? Would this change everything? As it turns out, the answer is a resounding yes. By incorporating the ability to learn from failure into OpenAI's GPT-3, researchers at the University of California, Berkeley have been able to improve its performance on various tasks by as much as 30%, Lee et al., 2022. As we've just witnessed, combining OpenAI with a simple yet ingenious feature has pushed the boundaries of what's thought possible in AI. The results are nothing short of astonishing, an exponential leap in language processing capabilities that's left even the most seasoned developers stunned. The true potential of this synergy is only beginning to be explored, and we're not just talking about incremental improvements, we're talking about a fundamental shift in how we interact with machines. Just think about it. With GPT-3 at its core, OpenAI has already shown remarkable aptitude for language understanding, text generation, and even creative writing. But what happens when you add this one key feature, a clever trick that's been hiding in plain sight for decades? The results are nothing short of revolutionary. We're talking about an